This is your class lesson for section 3.1 part 2, functions and function notation. We'll begin with number 1. Assume that y is a function of x. Rewrite each equation using function notation and then find f of negative 5 and f of b. So we already have this equation solved for y. So now we will use function notation, f of x equals y, and write f of x equals x squared plus 2x minus 3. Now we need to find f of negative 5. Now note, everywhere there's an x, we're going to put a negative 5. So we have negative 5 all squared plus 2 times negative 5 minus 3. That's 25 minus 10 minus 3, and that's 12. And then, likewise, f of b. So everywhere there's an x, we're going to put a b. So we have b squared plus 2b minus 3. Okay, let's look at b. Now b, we need to solve for y first. So I'll subtract 14 from both sides, and then I'll divide each term by 7. So we have 3x minus 2 equals y. Whoops. And then f of x equals 3x minus 2. We let f of x be y. Okay, let's go ahead and find f of negative 5. It's 3 times negative 5 minus 2. That's of negative 15 minus 2. And that's equal to negative 17. Okay, now let's go ahead and write f of x equals 3x minus 2 up at the top. And let's now find f of b. And as you note here, we're replacing x with b. So we have 3b minus 2. Okay. Now, let's just check this here. 3 times negative 5, negative 15. Yep, that's correct. Okay, let's go on to domain and range. Domain and range can sometimes be a little bit confusing, but I'll make sure to give a little extra explanation. The first thing we need to do is decide whether each relation defines a function. And this is an equation of a line. And then when we make this a function, let f of x be y, we now have a linear function. And I'm going to tell you that all linear functions have a domain and range of all reals. So let me just change this right here. So the domain and the range is negative infinity to infinity. Now, there is one example that if you have a linear function that is horizontal line, maybe y equal to 5, the domain there is all reals, but the range is just 5. So every, other than a linear function, other than a constant function, the domain and range of a linear function is all reals. Okay, let's go to B. Now I went ahead and graphed this in my calculator so that you could see the square root function. There's a couple of things I want you to know. First of all, the square root function looks like that, okay? And I want you to know that any x value you put in here, 2 times that value minus 1, the square root, you're really only going to have one output, which is one y value for each input. So you know right away that we have a function. Now, You can also use the vertical line test if you can graph it. So that might help. Okay? So now let's talk about the domain and the range. So what we have here is the range, as you can see here, is just all positive numbers. So we have 0 to infinity. So our range really goes up like that. Okay? Now our domain is a little bit different. Where is this point right here? What are we looking for? Well, let's go ahead and see where y is 0. We're going to let y be 0. So 0 equals the square root of 2x minus 1. So 0 equals 2x minus 1. If you square both sides, if you square 0, you get 0. 1 equals 2x, and x is 1/2. So the domain is going to begin, the x values begin at 1/2. Oh my. And get a tiny eraser here. And begin at 1/2 and go all the way to infinity. So I hope that that helps. Please use your calculator to get a good view of what these look like. Let's go to C. Before we let f of x be y, we need to go ahead and solve for y. And if we take the square root of both sides, we see that for every x value has 2 y values, because they'll have one is plus and one is minus. So we do not have a function. Okay? So if we don't have a function, we don't have to give the domain and range. Okay? This is an inequality. Anytime you see an inequality, it's not a function. It's a shaded area. Okay, and I went ahead and put this in my calculator. I'm having problems with my calculator coming on my screen and then slowing it down and stopping the recording. So I just want to make sure that I can still give you a good look at what these graphs look like and not interrupt this recording. So this is this function, as you can see. This is actually the line 1 right here, if you put this in your calculator, and this is a vertical asymptote. We're going to be talking more about that later, so don't worry about that right now. But what I do want to talk about is that this is a function. If you look here, every vertical line that you draw will only hit the graph one time. So yes, this is a function. Now, we do need to talk about the domain and the range. And so I want to show you real quick. Let me go ahead and erase this. I want to show you that when we look at the domain, we have to take x equal to 1 out, because if x equaled to 1, we would have 0 in the, we would have 0 in the denominator, and we can't have that. So on our domain, we will go from negative infinity all the way to 0, but not include it. And then we'll start at 0 and go all the way to infinity. Let me show you that on the graph. We want, that was supposed to be 1. I was thinking about the range. So let me begin. We want all of these x values, except we don't want to include 1. And so how we write that is 2 intervals. This is negative infinity going all the way to 1. And then now we're jumping over 1 and going from 1 to infinity. Now, because we don't have the value 1, we lose a range value. So I'll go ahead and take this off. And let's talk about the y values. What do you notice? Y doesn't seem to ever be equal to 0. Right here. So we actually have a horizontal asymptote. This will tend to it. So that makes our range from negative infinity. We don't want 0, and we want everything above. So from negative infinity to 0, and then we're going to go from 0 to infinity. And we do have a function. Okay? Now, for each function below, find f of 3, and you will really like this, okay? We'll start with algebraic. And so finding f of 3, everywhere there's an x, we're going to put a 3. So now we have 3, times 3 minus 7, which is 9 minus 7, and we have 2. So f of 3 is 2. Now you'll like this. Look at b. F of 3 asks you for a y value when x is 3. That's what it's doing. So we look until we find x is equal to 3 and the y value is f of 3. So f of 3 is 1. Okay, let's go to C. When x is 3, I thought I had my highlighter. When x is 3, y is 5. So f of 3 is 5. This is asking for the y value. Okay, and let's look at D now, and this is numerical here. And you can also consider this the numerical way when you're given values. And now we look at the graphical way to find function values. So f of 3 means what is the y value when x is 3? So I'm going to look up until I get to this point right here. So when x is 3, y is 4. So f of 3 is 4. Okay, we will end this lesson with determining whether each graph is the graph of a one-to-one function. Now, these are all functions. They all pass the vertical line test. That's not the issue here. They are already functions, but we want to know, are they a special function? Are they one-to-one? So we talked about that a one-to-one function, any horizontal line that you draw, can only hit the graph one time. And that happens in A. So we have a one-to-one function. But look what happens in the example B. Well, look, I only hit the graph once there. Well, maybe twice there. But I only hit it once there, right there. But it says any horizontal line. And look what happens. I'm hitting the graph twice in all of these places. So this is not a one-to-one function. And that concludes this part 2 of section 3.1 video.